Welcome to Chemical Podcast. Today, we're exploring percent composition, how scientists measure the exact makeup of compound, from the elements in our food to the materials around us. Join us as we break down why percent composition matters and where you'll find it in your everyday life. Let's start with a little history. The concept of percent composition has roots in the early days of chemistry, as scientists sought to understand what makes up different substances. In the 18th century, influential chemists like Antoine Lavoisier and Joseph Proust were exploring the building blocks of compounds. Proust formulated what's known as the law of definite proportions, which tells us that a pure compound always contains the same elements in the same ratios by the mass. This idea set the stage for calculating percent composition, giving chemists a way to express the exact mass of each element within a compound. So, what exactly is percent composition? Simply put, it's a way of expressing how much of each element contributes to the total mass of a compound. Think of it as finding the percentage of each part of a compound by mass. For example, in water, or H2O, we can calculate the percent of hydrogen and oxygen that make up its total mass. Percent composition helps us understand the makeup of a compound in a precise, measurable way. Why is percent composition important? Why do we need percent composition? It's a vital tool in both the lab and various industries. First, percent composition helps chemists to confirm the identity of compounds by comparing their calculated values to the known standards. In industries like agriculture, food, and pharmaceuticals, percent composition helps in formulating products with exact ingredient amount, so they meet standards and work as intended. For instance, choosing fertilizers with high nitrogen content can boost crop growth. In environmental science, percent composition allows for careful monitoring of pollutants, making it easier to manage and reduce their impact on the environment. Moving on, we have here the formula used in percent composition. To calculate percent composition, chemists use the following formula. Percent composition is equals to N pertaining to the number of atoms of element in the compound multiplied by M, or the mass of the element, over M, or the total mass of compound, and the result of that will be multiplied by 100. To make it more understandable, I have put examples to each variable present in the formula. For the number of atoms in this example, in H2O or water, we can see that there is a subscript of 2 for hydrogen. Therefore, we can say that hydrogen has 2 number of atoms. Then, the atomic mass of the element of hydrogen is 1.00784 grams per mole. This can be found in periodic tables. Now, in the formula given, in the denominator, we have here M referring to the total molar mass of a compound. In H2O or water, the total molar mass is 18.01528 grams per mole. Now, to calculate the total molar mass, we have here the formula number of molecules multiplied by mass of element. Example, in H2O, hydrogen contains 2 number of atoms. That's why it will be multiplied by 1.00786 grams per mole, which is the atomic mass of hydrogen. It will then result to 2.01568 grams per mole. That will be the elemental mass of hydrogen in H2O. Same process will be applied with oxygen. When you add both values of hydrogen and oxygen, the total molar mass of H2O equals 18.01528 grams per mole. Now that the variables involved in the given formula was already explained, we will now apply it. We have here the given compound, which is H2O or water. The number of molecules of hydrogen is 2. the mass of hydrogen is 1.00786 grams per mole, and the total molar mass of compound as computed previously is 18.01528 grams per mole. What we need to find is the percentage composition of hydrogen. To compute, we will use the same formula previously explained. We have here 2, which is the atomic number of hydrogen in H2O, multiplied by 1.00784 grams per mole, or the atomic mass of hydrogen, all over the total molar mass of H2O or water, which equates to 18.01528 grams per mole. Multiplying the mentioned variables in the numerator, it will give us a value of 2.01568 grams per mole. We will then divide our numerator 2.01568 grams per mole to our denominator 18.01528 grams per mole, and then it will then give us the value 0.1188, and then it will be multiplied by 100 to find the percentage of hydrogen. The result will be 11.188724, or if we round up, it will result in 11.19%. Therefore, one molecule of H2O contains 11.19% of hydrogen. Now, to make the process more organized, let's break down the steps to calculate percent composition. Step 1. Identify the mass of each element, either from experimental data or using molar masses from the periodic table. Step 2. Find the compound molar mass by adding up the atomic masses of each atom in the compound. Finally, in step 3, divide the mass of each element by the total molar mass of the compound, then multiply by 100 to get the percentage. Following these steps will give you the percent composition of each element in the compound. Moving forward, here are the example worded problems. Soil that is already depleted of its nutrients needs fertilizer. One of the nutrients needed to replenish the soil is nitrogen. If you are an agricultural technician helping a farmer, which among these fertilizers are you going to use? Show your computations to convince the farmer about your choice. The following fertilizers are identified as ammonia, ammonium sulfate, and ammonium nitrate. Now, we will compute the percentage composition of nitrogen for each fertilizers. Now, for ammonia, let's start first with step 1, which is identifying the element masses in the compound. Ammonia's chemical formula is NH3. Ammonia contains only one atom of nitrogen, so it will then be multiplied to 14.01 grams per mole, or the atomic mass of nitrogen, and it will result to 14.01 grams per mole, and that will be the elemental mass of nitrogen in the compound ammonia. As for hydrogen, since that it has 3 atoms, it will then be multiplied to 1.01 grams per mole, or the atomic mass of hydrogen, and it will result to 3.03 grams per mole. Now for step 2, which is identifying the total molar mass of the compound, we will add the results from the element masses of nitrogen and the element masses of hydrogen, which will equals to 17.04 grams per mole. Same process will be applied to ammonium sulfate and ammonium nitrate. Since that in our first and second step we already identified the values of our variables, we will now substitute it into our formula. For ammonia or NH3, the percent nitrogen is equals to 1, or the number of atoms of nitrogen in the compound, multiplied to 14.01 grams per mole, or the atomic mass of nitrogen, divided by 17.04 grams per mole, or the total molar mass of NH3, multiplied to 100. It will then give us a result of 82.2% of nitrogen in ammonia. Same process will be applied to ammonium sulfate and ammonium nitrate. Now, ranking all the percentages, ammonia has 82.2% of nitrogen, ammonium sulfate has 21.2% of nitrogen, and lastly, the ammonium nitrate has 35.0% of nitrogen. We can therefore conclude that ammonia contains the highest percentage of nitrogen and should be used as the fertilizer by the farmer. Now, it's time to challenge yourselves. Try to answer this. Number 1. Glucose is a 6-carbon sugar, which is also known as the blood sugar. It's an energy source that fuels our body. How many percent of carbon is present in glucose? Number 2. The fuel value of the hydrogen-containing fuels depends on the mass percentage of hydrogen. Rank the following compounds based on their fuel value, with 1 as the highest and 3rd as the lowest. We have here ethane, propane, and ethanol. The answers to the following problems will be shown at the end of this video, and for the podcast listeners, it will be mentioned at the end of the podcast. Thanks for tuning in into our Chemicap podcast. We hope this gives you a clear snapshot of percent composition and its role in science and industry. Don't forget to subscribe and keep exploring the world of chemistry with us. Thank you. The answers to the problems given previously for item number 1, 39.99% of carbon is present in glucose. For item number 2, we have rank 1, ethane, 20.15% of hydrogen. Rank number 2, propane, containing 18.32% of hydrogen. And rank 3, we have ethanol, containing 13.15% of hydrogen.